Hello everyone, my name is Viktor. I'm developer dedicated at AWS, and today we are going to speak with you about Kubernetes. Honestly, it's my favorite topic. One of the main reasons because before I joined to AWS, I worked as DevOps engineer more than 10 years. And if you understand Russian, you can subscribe to my own personal channel, DevOps Kitchen Talks, where I speak about DevOps topics, some news from DevOps area, and not only. And yeah, what we are going to do just like today, we are going to speak with you how we can scale Kubernetes. But before we jump into the content, my first question, who knows what exactly Kubernetes is? Okay, okay, couple hands, okay. Who knows how to scale Kubernetes? I mean, like, who works with cluster autoscaler? Yeah, one hands. So who else? Yeah, couple hands. Okay, good. So this means like I have the right content for you. I hope so. I will try to explain on different levels. I mean, like I will start from super simple and hope we'll finish with more advanced topic. And as usual, if you have any questions, you can reach me out in any end, like I mean, in LinkedIn and Telegram, and maybe something else. I know. So anyway, just like let's start from the first topic. How in general we scale inside in Kubernetes. When I'm speaking about the scaling and the main benefits of cloud in general, it's a scaling mechanism. When you say for me, just like a cloud is cheap, I would say no, it's not cheap if you're not using the right way. Cloud is cheap when you scale up and down on the right moment of time. I mean, like if you don't need this amount of resources, I don't know so much of CPU or memory or maybe storage, but you're still consuming it, it means like you're still paying for that. And how we can scale inside in the Kubernetes? Absolutely the same approach how we do it outside of the Kubernetes, like in our cloud provider, for example, in AWS. The first one is horizontal and vertical approach. The first one, of course, it's horizontal. The best way if your application is ready to be scaled horizontally. I mean, when I say like horizontally, it means like you can add additional amount of node ports inside to your application, and you can spread your load between all of these nodes. For example, in horizontal pod of scaling inside the Kubernetes, we have a concept which is called HPA, horizontal pod of a scaler, and it means like when I need additional pod, I scale and edit one more pod, next one more pod, and so on, so on. And based on the metrics, I mean, like when I say based on the metrics, it can be your CPU, it can be your memory, or for example, you can integrate with external metrics and you can do some advanced scaling based on the external metrics like I don't know some events happened and so on. But originally horizontal pod of scaler scale when you have some CPU load, like for example 80% you achieved, it means like you need more resources. Vertical autoscaler. Vertical autoscaler to compare with horizontal, it means like you extend the size of the instance. It was one of the way how we scale. I mean, like 10 years ago, if you have one server, and for example, if you want to scale, you have to order another one, which will be the bigger. Bigger, it means like I know not one CPU, it will have two CPU, four CPU, eight CPU, and so on, so on. It's vertical pod of a scaler. When we understand like okay, we need more resources, we identify it somehow like again based on the metrics and say for next one we need more CPU or for example more memory. Vertical pod of a scaler is the best approach if you're familiar with Kubernetes and you know how sometimes can be terrible to identify what the resource limitation, what the resource limits, request limits should be defined. And for example, if you're working with Java application, sometimes it's so terrible to say for this application, I'm going to use only, I don't know, 256 megabyte of memory, and it will be enough. Maybe for Java, it will be not enough. On the start, yes, but when we'll have a lot of traffic, no. So it was only related how we scale inside the Kubernetes. I mean, like we have one box, and for example, I know like 10 nodes, and that's it. What about if you want to scale outside of the Kubernetes? I mean, like if we need to add more resources, like for example, to use our cloud provider. What we can do? The first one, of course, it's cloud autoscaler. It's default solution. It's open source, and you can install and use it almost everywhere. And let's see what exactly will happen if we need to add more resources and when it will happen. For example, I got some new load and I see there's a couple of my pods currently in the pending state. Pod is like smallest instance of something inside the Kubernetes, like your virtual machine. You can say virtual machine. Oh, it's like similar. So cluster autoscaler identifies that we currently have some pods in the pending state and starts the process that we need more resources. For pod autoscaler, for cluster autoscaler, you have some abstraction which is called not group, and not group communicate with ISG. With ISG. ISG is autoscaling group. And for example, if you have some load, for example, for your web application, you have to create one ISG. If you have your load, for example, for machine learning, you need another ISG. If you have your, for backend, you need another ISG, and so on and so on. So ISG requested new instance, like communicate with AWS, and we remember for autoscaling group, we identified three main parameters. The first one, it's minimum minimum amount of EC2 instances is going to be in this group. The second one is desired, and the last one is the maximum. How much in general, how many resources can be inside in this group. So as soon as we get new EC2 instance, we add it to our Kubernetes cluster and started to work with the Kubernetes, with new instance. Let's see it's like a more real example how it looks like, from visual part perspective. Currently, I have only one autoscaling group, which is part of, consists of virtual machine, which provide for me 4 CPU. And currently, I have 2 free places, like for 2 CPU. I got new load, and currently my load, this pod is currently in the pending and waiting for some free places of resources. Of course, by default, Kubernetes has a scheduler. Scheduler identify, okay, I have some free places. This one, like these 2 free white boxes, and put my load to these free boxes. And the next one is requested some new resources. And by default, we requested the same size of instances. For example, currently I have instance which is 4 CPU and some amount of memory. For us, currently doesn't matter. It means like I will also really request the same size of instance. And I will put this load to these instances. And what we see that we are not consume all of the resources. At least one EC2 instance currently more than half free. We are not using it for our own process, for our application, but we still pay for that. For that reason, I started my conversation with you that cloud is cheap. Yes, if you can correctly consume it, if you correctly configure it, your cloud resources. So its main drawback of cloud autoscaler, cluster autoscaler, and how Karpenter can solve this problem. Karpenter tried to, to look at this problem of the scaling process from another angle. And if you look at the whole pipeline, how we scale, what the components we need for cluster autoscaler, we will see that, first of all, we have application. Application is currently in pending state. Cluster autoscaler, should be some controller. We need autoscaling group, and only after that we communicate with EC2 API. For me, it sounds like very familiar when we had in Kubernetes Docker, and Docker was additional layer. It's not bring some value. And here goes also ISG. We don't need ISG. We don't need cluster autoscaler. Karpenter totally just like say, let's delete these 2 components and directly communicate with EC2 API. And when we can communicate with EC2 API, first of all, we can get the actual information about instances. What the instances is available. Maybe some of them should be located in some specific availability zones and so on. And if you look at the same example, as a previous, again, I got a load to schedule some amount of pods. In my case, it's 7 pods. First step, again, will be the same. Scheduler identify, like I have 2 free boxes, 2 places for 2 pods. Put this load on these instances. And for next one, request exactly the minimum size of instance which can fit this amount of resources, this amount of CPU. I understand like 7 CPU, in our case it's 5, it means like the closest it will be with 8 CPU, and it will request the node which can fit directly this amount of instances of this pod. We currently speaking only about to scale out. I mean, like when we add additional resources, but we also should be prepared when we don't need these resources. I mean, like when we scale in, when we delete, just like not need all of these resources. What will be the case is with the Karpenter? Again, just like we delete these resources, we don't need it. And what we currently see, we see that we have our free node, and it means like we can delete it pretty quickly. And as soon as we communicate directly with EC2 API, we can do it much quicker if we compare with cluster autoscaler. And in Karpenter, it's provided for you two main approaches. The first one, how we can delete this node. The first one is termination. Termination has TTL, it's timer, and when Karpenter identifies this node is free, it starts the timer. After 30 seconds, after I know like 1 minute, like we start the deletion process, like delete this node. Another approach, it's from my perspective, it's one of the main and interesting feature from Karpenter, it's consolidation. What consolidation means exactly? So previously, before this feature, how Karpenter provide for you resources? It's understand like how many resources do you need, communicate with these two API, and provide these resources for you. When you enable consolidation, Karpenter will run this procedure like constantly, like every minute, every 2 minutes, to identify how many resources exactly I currently need to proceed with my current load. And it will simulate and, for example, identify that maybe some of the nodes I don't need it. Maybe I can delete some of the node and move my load from one node to another one. Or maybe I can request new node, which will be cheaper, and I replace old one. So it's how consolidation works. But if you're not familiar with pod disruption budget and you just like, hey, let's enable more consolidation, it's not the right approach. Be familiar with pod disruption budget. Pod disruption budget will guarantee that you are not lost the whole of your application. For example, you can say, I want to save at least 50% of my load available. And if I see the situations that I have to turn on some of the EC2 instance, and it means like I can lose more than 50% of my application, pod disruption budget, save it, and Karpenter will understand that I cannot currently delete this node or this amount of the node. Okay, what exactly I need to start to work with the Karpenter? Of course, first of all, we have to install something inside our Kubernetes cluster. It will be our controller. And the second part is our customer source definition. It's our provisioner. I understand it's not possible to see it. For that reason, I prepared it a little bit bigger. What exactly we can configure in provisioner? I mean, like for our provisioner Karpenter. First of all, we can identify what the purchase option we prefer to use. Purchase options, I mean like if you're familiar with EC2, I believe you know that exists on-demand instance when you pay like the higher price, or you can use spot instances, which can save you up to 80%. And I highly recommend if your application is ready for spot instance, try to migrate to spot instance. You can save a lot of money. The second one is like CPU architecture. You can say if some of the my load is ready to run on Graviton instances, on IRM instances. Again, if you're not familiar with Graviton, super highly recommend to look at them because again, you can save a lot of money because it's cheaper, faster, and so on. The same as like my MacBook with M1 processor, faster than in like on the previous generation. We can select what kind of instance types is available for me. I mean, like, for example, you prefer to use, I don't know, like only M5 large instances or M5 2x large and that's it. Because you, I don't know, like, you committed to use only these instances and you have some good price for all of them. Or you can identify what availability zone is available for your load and maybe some of them is not. I mean, like, currently, I use in operator only in, but in fact, you can use not in. It means like you can say not in this availability zones. Please don't run my EC2 instance in this availability zones. Also, we can configure taints and startup taints. If you're familiar with Kubernetes, I believe you know what is taint, but I want to explain a little bit what is startup taint. For example, you need to work with some network interface inside in your Kubernetes cluster. And before to proceed with load inside in your Kubernetes cluster, you have to configure this CNI. And for that reason, you can use startup taint. Karpenter will create startup taint. It means like nobody can schedule anything inside in this node. And your CNI will be responsible, its daemon set will be responsible to delete this startup taint. And as soon as this taint will be deleted, it means like I can proceed with my load. Of course, I can work with any constraints. I mean, like from Kubernetes perspective, I mean, like I can say maybe I have some not selector or maybe not affinity, anti-affinity. All of the stuff works correctly with Kubernetes. I mean, like with Karpenter, and Karpenter will identify and understand these constraints. Also, we can configure our kubelet. It means like if you have some custom configuration, some custom, like specific configuration for your kubelet, you can do it through the Karpenter. You can say, I don't know, like for example, you have some system reserved for your, I don't know, maybe services, maybe some daemons and so on, and you prefer to save at least one CPU and 2 GB of memory for these resources. Also, the biggest question with the Karpenter, how we can density, how we can spread amount of pods per node, and how I can limit and say, for example, not more than 20 pods per node, how I can do it. And if you're familiar with EKS, you also know that in EKS you have a limitation, some amount of IP address which you can provide it, and it's limited how many pods you can schedule inside in one node. So with pod density, what you can do is the first one is dynamic. And it means like you say, hey, I want to scale not more than 2 pods per core, I mean like per CPU core. Or another one, when you say static, how many pods is available, can be scheduled inside in this node. Like for example, in my case, it's only 20. So I believe you're a little bit worried about like this slide deck, and I think it's a good time to switch to demo part. As usual, just like this QR code will direct you to GitHub, where I put all of this, like what exactly you need to do to repeat this demo. But be careful, it will cost pretty a lot of money, because you will see in a couple seconds why. So what exactly we are going to do with demo? The first one, it will be how to start, how Karpenter works. I mean, like super initial, the first steps, how Karpenter requests the resources, how we can scale. It will be our first part of the demo. Also, at the end of this demo, I will show you, like a scenario when you can create, for example, spread some amount of load between on-demand instances and spot instances. In my case, it will be 50-50%, but in your case, it can be, I don't know, like 70%, 30%, 80%, 20%, up to you. And the second demo, which I will run just like in the start, because it will take some time, I'm going to run 3,000 pods with a batch per 500 pods per deployment. It means like I will have 6 deployments, and in every deployment we will have 500 pods. And why I want to run this high load? I want to show you what the efficiency usage of resources Karpenter will achieve. I mean, like how many resources we requested and how many resources we consume, like what our threshold will be. And the last one, how we can quickly delete all of these resources. So I think I will switch to another microphone, because I will need to all of my hands for this demo. Yeah, let me turn off this microphone. So now, thank you. It's too early. So where is my mouse? Yes, it's my mouse. I see you still see my PowerPoint. Okay, let's exit. So what I currently have, currently I already installed and prepared 2 Kubernetes clusters. Both of them, it's like 1.25 version. Honestly, it's absolutely doesn't matter. And for both of this Kubernetes cluster, I already installed and configured Karpenter. Let's see how it looks like. So we have currently two environments. I need your attention, just like guys. Really, it's. But I understand that it will be a huge demo, but anyway. So the first one where we are going to start some simple interaction with the Karpenter. The second one it will be high load. Let's see what exactly we have in my high load environment. Let's check how many pods do we have in total. I mean, like across and all of namespaces. I use my alias K. It means like kubectl. If you're familiar with Kubernetes, you know like kubectl. It's your default CLI, how you can interact and just like in general communicate with your Kubernetes cluster. And as you can see in namespace Karpenter, I have two pods. First of all, these two pods is responsible for my Karpenter controller. I mean, like when I create some custom resource through this controller, I will create and interact in general with EC2 API and so on. Also, what else I have? I installed some additional visual, like instruments. It's called kubeops view, and it will help me to visualize. Of course, if yes, it works. It helped me to visualize how many nodes currently I have and what the spread of pods per node currently we can see. So by default, currently when you deploy your Karpenter controller, it will deploy and spread between two nodes. Why two nodes? First of all, because it's like resiliency. In case if you lost one node, what will be in with your Karpenter controller? And currently, we have two nodes. It's my managed node which I created before the demo. It's not a part. I mean, like you can install your Karpenter, for example, inside in Fargate, or you can install like as me in managed node group. It's like it's not big deal. So here we have kubeops, like which is provide for me this functionality to see what exactly happened with my nodes. And the second one is my Karpenter. I believe you can like see Karpenter pods. So for first demo, for high load, we are going to run my high load, huge load of this, like applications. Of course, I prepared some script. All of the scripts which written by DevOps is written in Bash, of course, because Bash is the best language. And please don't say for me that the Go or Python is better. So what exactly I have in this Bash script? It randomly selected, like between two array. The first array is CPU options. The second array is memory options. And as you can see in the first one, 250 millicores. In Kubernetes, you provided the resources in millicores. And the second one, it's my memory options, up to 1 gigabyte, and for CPU, up to 1 CPU. So I'm going to run the command. It's this one. So yes, what exactly is going to do? Just like it's going to create 3,000 pods, as I promised. For every deployment, it will create 500 pods. It means like you will create 6 deployments. Let's run this demo, and I hope everything will work fine because demo is usually it's demo. Something can be broken, and let's switch to the first environment. It's our main environment. We are going to spend like maybe next 10 minutes. So the same, absolutely the same configuration. Let's double check that we have the same amount of pods, the same amount, like the same configuration. I have a Karpenter with 2 pods. Currently is running just like 6 hours ago, just like specially for you. I prepared this demo environment. And what I'm going to do, I'm going to run my first load. This load will be looks like this one. It's manifest, it's a deployment. Let's see a little bit, like in details, what exactly I'm going to do. It will be inflate deployment with 10 pods, like how many replicas I'm going to run. And what's most important for me is like how many resources I'm going to request. In my case, it will be 250 millicores and 256 megabytes of memory. And also from like from price perspective, I prefer to use only spot instances. So let's run this manifest. Let's clear the screen, just like this. You will be able to see what I'm doing. K, it's again kubectl apply -f. Here start, I believe, yes, start. 10 pods, it's my current manifest, and I run it. Meanwhile, I'm going to show you the logs of Karpenter, and we will see how Karpenter proceeds with this request. So, as you can see here, Karpenter say, I need resources to proceed with 10 pods. Karpenter calculate how many resources exactly I need. I will need a little bit more than 2.5 CPU, like in general 2600 blah 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 milli-cores, and also what the amount of memory I need. And you know what's the most interesting from my perspective? That Karpenter also understands like I need to schedule not 10 pods, I will need to schedule 12 pods. Why 12? Because in Kubernetes you can install daemon set, and the daemon set it means like you will run some load for every node. And Karpenter understand like I need to schedule not 10, I need to schedule 12 because for a new node I will also need to schedule additional daemon set. Karpenter communicates with EC2 API and figure out that currently for spot instances, because we request spot instances, found more than 150 EC2 instances which can fit this request, like these resources, and provided for us in EUNOS 1C some instances C5DX large. Let's check from visual part. Let's refresh this page. Yeah, so as you can see, we have currently one more node. It's my managed node, like these 2 pods on the button, on the top, on the button, it's my daemon set and some system pods. It's my inflate deployment. Okay, what will be happened if I, let's say, scale my application? For example, currently I have 10, but I'm going to scale like up to 60 pods. I'm going to scale this application to 60 pods. So let's see what will be happened in this case. And if we currently switch to visual part, we will see that currently in the queue, like we need something happened with this application. Let's refresh a little bit. I lost one node. Something interesting. Let's check to real Kubernetes. I mean, like this one, it will be more real than this open source product. Let's see. So currently, as you can see, I added one more node, which is currently is not ready, but and the size of this instance is C5A4X large. It's like understand how many resources, what's the size of instance I need to provide to schedule this new amount of load. And what will be interesting, yeah, here we go. We see that like we added new instance, and for this demo, I enable consolidation, and you see that currently what's really happened. Karpenter understand that I have currently a bigger box of EC2 instance where I can move my previous 10 pods to this new created instance. And I can delete the previous one, don't pay for that, because I still have enough resources. I mean, I still have enough CPU and memory in this big node. So it's how consolidation works. I mean, like how we try to save your money. I mean, like Karpenter try to save your money, just like delete previous node and migrate all of the pods to the new one. But again, be really careful and identify your pod disruption budget, because in this case, you can lose your application. But with pod disruption budget, you can say, as I said previously, 50% should be available and Karpenter will work correctly. So it was the first part of my demo, and as you remember, I promise and say that we are going to deploy my application 50-50. It means like currently I want to deploy some new application and spread this load between on-demand instances, which cost like pretty a lot of, and on spot instances, which cost at least half of the price of on-demand instances. To do it, first of all, I'm going to delete my current deployment, just like kubectl deployment, delete deployment inflate. Also, I need to delete my provisioner. Currently, I have only one provisioner. It's default provisioner. Provisioner is custom resource for my Karpenter. So I'm going to delete it and deploy another provisioners. Let me show what the provisioners will be looks like and how we can achieve this spread between spot instances and on-demand instances. So the first one, it will be my on-demand provisioner. Yes, this one. And I'm going to add some custom label. It will be capacity spread. And for these labels, I'm going to add just like a number, 1, 2. In your case, it can be 1, 2, 3, 4, 5. Like up to you how many, what the percentage you want to achieve. Also, I said I'm going to run 30 nodes per node. I configure it on kubelet configuration and said I don't want to run more than 30 pods per node. For me, it's very important because it will be my web application and I want to spread between a lot of nodes. Also, from limit resources request, I said like not more than 500 CPU, and the consolidation is enabled also. The same stuff will be for spot, but for spot instances, for spot provision, what the difference will be? It will be only in this capacity spread. The value will be 3 and 4. So currently I have 4 numbers, like say 1, 2 for on-demand, 2, 3, 4 for spot instances. It's how you can create your proportion. Like for example, for spot, you can say 2, 3, 4, and this means like 75% will be deployed on spot instances. So first of all, what we have to do, apply our new provisions. Kubectl apply -f provisioner demand, and the same stuff with spot. Sorry, spot. Yes. Here we go. So we deploy. Let's double check. Let's me clear this screen and double check to get provisioners. So we currently have 2 provisioners, demand and spot, and I'm going to run my application. It will be the same inflate instance, but in this time it's going to run 600 pods. Let me show you how this manifest looks like. So again, the same inflate with replica is going to 600 pods. The same amount of resources I'm going to request. And what's interesting, I use topology spread constraint. It's how exactly Kubernetes scheduler will help me to achieve the spread between spot instances and on-demand. Let's run this manifest because it also will take some time. So let's back meanwhile. And I said, based on topology key, my custom key, which I created for inside in the Karpenter, because by default, when you use topology spread, most probably you will use like between availability zones or maybe between some your nodes and so on. But in my case, I create a custom label and say topology spread. It's my capacity spread, and I don't want to schedule more than one instance. Try to not schedule more than one instance. So let's check how many nodes currently I have. Again, just like I prepared some, like bash script, not bash script, it's like one line of the code, which can help me to see what's the current state with all instances. And from the right side, like from this one, capacity type, you can see some of them it's currently created and it's spot instances. Some of them it's on-demand instances. And it's how exactly I'm good, just like Karpenter currently is working to provide for me the right amount of resources for these 600 pods. And also let's go to the Karpenter log because I think it will be also very interesting. What we see that Karpenter request proceed with this 600 pods and split it on 30 pods per node. But what's interesting, you can see 28 pods per node. Why? Because we also need some space for diamond set. So 30 pods per node. And also you can see currently is running some Cardon and delete some nodes. Why? Because we enable consolidation, and Karpenter try to understand, okay, the current configuration is good or not. Let's check to visual part and see how it looks like currently. So we requested 600 ports and spread between on-demand and spot instances. Let's double check that's what's the current state with our nodes. A little bit, yes. No, please. So just like I'm not going to calculate, just like spot on demand, just like trust me, I'm engineer. Yeah, so spot and on-demand instances, and like it was the second, like the last part of the first demo, and you remember that we have some high-low demo. I mean, like this part where I runs 3,000 ports and spread between deployment 500 ports per deployment. Let's see from visual part how it looks like, how many nodes I requested and how many ports I'm currently deployed inside to my Kubernetes cluster. Here we go. It's how it looks like. And what I wanted to show, like not the amount of green boxes on the screen. No. I want to show you how I consume these resources. For that, I'm going to use this one. Yes, this one. What exactly is? It's kubectl resource capacity, and is going to sort by CPU request. And sorry, and it show me that what's the current resources I requested, and I achieve 99%. It means like, yes, I understand maybe from real usage it's not 99%, but from request resources I requested for 99%, and it's currently 99% is all the resources which I requested is going to use. So it's how exactly I to put all of my resources in the Kubernetes cluster. And super the last one part of this demo, I'm going to delete the whole of this workload because 3,000 ports, it's not so cheap. Let's do it. And meanwhile, it's going to happen just like I requested to delete these ports. Let me double check. Yes. Yeah. So in reality, you also, I believe you understand, like for Kubernetes, it needs some time to delete all of these ports. And what's currently happened? Scheduler Kubernetes API proceed on deletion all of these ports, which I currently don't need it. So that's it. Meanwhile, it's going to happen. Like we will see how quickly and how fast Karpenter will delete and free these resources. We have a time for your questions.
Hello.
Closer
Thanks a
to.
lot for the insightful presentation. I have a couple of questions here.
Yeah, I see. You just like type it in your mobile phone.
I was
I remember you. I remember. I look at you the whole presentation. It's just like you not stop typing. So you have at least 10 questions, yeah?
No, three. Three exactly.
Three. Okay.
Connected.
Okay.
The first one is about the spot instances.
Okay.
So I love spot instances. Those are cheap. But those are not always available, the ones that you want.
Of course.
So what happens if the resources are not available?
It's the one biggest, from my point of view, benefits of Karpenter. If you don't limited amount of type of instances, it will connect to EC2 API and request and get all of available spot instances in this availability zones in this region for you. You can identify and say, hey, I'm not going to use some another instances like which is bigger than, I know, more than 8 CPU, for example, and less than 2 CPU because you don't want some micro instances. So you can do it, and in general, my recommendation, just like AWS recommendation, don't limit it with 2, 3, some small amount of spot instances, because yes, in this case, you can be in situations that this spot instances is not available. Just like leave this, like arrange what kind of instances you can select for your load, and Karpenter will try to identify. It's one of the biggest benefits from the Karpenter that you don't need to think, okay, what kind of EC2 instances will be cheaper for me in case blah blah blah. Karpenter will do it for you. When Karpenter selects the right instance, it's selected based on the price, the current price of EC2 instance. But if you identify that I have only two type of spot instances, I know like M5 and M5 2x large, and that's it. And this instance is not available. Karpenter will use on demand if you allow it in your provisioner, because in provisioner you can say spot instances, comma demand instances.
And is there a kind of what is the order? Is there an order there?
Order will be based on the price.
Oh, okay. And maybe a follow-up question about this is, you had an example where 5 calls were scheduled by Karpenter.
Okay.
It was in the slides. And all, yeah. Yeah, over there. Just go down. Yeah,
This,
yeah, there. So those 5 calls were placed on the new node. So what will happen when I delete, let's say, 2 of these calls there?
If you enable consolidation, Karpenter will run the procedure like, okay, currently I need resources for not 5, for 3 pods. Maybe I can request new instance. It will take a time. I check it, just like it will take a time, and I mean it will not, like in 1 second, and will request for you new node. Now it will take a time, like 5-10 minutes, but it will understand like you don't need this amount of resources currently, and you can request new instance, which will be cheaper, but this instance will just fit your load.
Thank you.
You're welcome.
Yes, that's it. Thank you.
You're welcome. Meanwhile, just like we are switching to another question, as usual for AWS, it's very, very important to hear your feedback. And if you can leave your feedback in my QR code, I know maybe we have some separate QR code, but if you can leave it for me, your thoughts about this presentation, maybe the demo was too much, maybe slides was too much, I don't know, like, please write me and just like evaluate the session, and I'm ready to the next question if we have some.
I can figure out.
Okay.
So when we are setting up an EKS structure, are we going to hand over the whole node management to Karpenter instead of autoscaling group and or EKS node group?
Yes, that's correct. Oh, just like I didn't catch your question. Because in class autoscaler, what you have to do, first of all, you have say I'm going to use manage group. For manage group, it's going to create your ISG after scaling group, and for every type of load, let's say.
Launch template as well.
Yes, of course. But for Karpenter, you don't need to care all about that. What you can do, like for example, if you need your custom images, you can do it. I didn't show it, but you can do it. Like I mean, for example, you need to install some custom, have some custom installation or custom AMI you're going to use, you can do it. So Karpenter will request all new instances for you without, like to care about what's the template, what's the size, all of the stuff.
Let's say I was using AMI version 1.
Okay.
I want to migrate to AMI version 2.
Okay.
With any node group or ASG, you create a new launch template.
Okay.
You deploy. How about in Karpenter?
It's a good question. It's a question related how I can update my instances. Yeah. In provisioner, you can identify one parameter which is called like TTL, time to live for this machine. Let me a little bit explain what exactly is. So when you create your new instance, you say, I'm going to allow to leave this instance, for example, for 1 month. And in 1 month, it will automatically delete, and Karpenter will request a new one. And how you achieve this up-to-date instance state. So it means like it will delete this instance, request new one, you identify like a new one, it will be version 2, it will request like in 1 month. You can initialize your if you see some security issue, like It's very important to up to date today, like because we have some malicious or we some attack currently. You can say I'm going to delete some of the nodes and start manual process. But by default, what's initial, like how we can say I want to have all of my instances up to date, it's time to leave for your instance. And for next time, when it will go into request, new instance, it will request with new version, like with new version of OS, security updates, install, and so on and so on.
Okay, that's my first question. For the second question, if I may, you mentioned HPA and DPA and Karpenter. Let's say
Karpenter currently working only with horizontal port autoscaler.
I got me.
Yeah, I started this from HPA and DPA just like to show how we can in general can scale, and Karpenter try provide for you, not only horizontal but also vertical scale, because in case if you need to provide some EC2 instance which is bigger than the previously one, in ISG you have to create a new ISG group, because in the best practice you have to put to ISG one type of instances. I don't say one instance, I say one type, like for example with 4 CPU, and select from different instance families. In Karpenter you can scale vertically, say like I need currently bigger machine because I got request for for analytics job, and for this analytic job I need like 16 CPU. In ISG you need to create in cluster scaler you need to create separate ISG with 16 CPU which can fit this load and so on. So Karpenter can do it for you just like without worry.
What about scheduling? Like, let's say I'm in. I know that for a fact every Sunday my request will drop to 20%. So I want to store all my nodes, or can I do something like a cron job or scheduling with Karpenter, or no need to that since it will destroy?
Outside of the Karpenter, you cannot do it, but you can install and use some external tool which integrate with Kubernetes. So Karpenter is super integrated with scheduler. If scheduler say I don't need these resources or I need more resources in some time, like as you said, like a cron job, please go ahead and use it. Say for scheduler, and scheduler will say it for Karpenter. So first of all, you have to say it for your Kubernetes scheduler. Okay.
Thank you.
You're welcome. More questions?
What about complex delete machine? For example, I want memory optimized machine or CPU.
Okay. So you can make this constraint inside in your deployment. For example, you can say I want to put my load only in some type of instance family instances, or you can create separate profile, provisioner profile. As you remember, for on-demand and spot instance, like to spread this load, I create two provisioners. So you can create two provisioners, and inside in your deployment, identifying your constraints where you're going to run your instances. But by default, Karpenter don't care what kind of, it should be CPU optimized or memory optimized. If you don't provide any constraint inside in your deployment, it will try to find the cheapest instance for you, not CPU optimized or memory optimized. If you provide some constraints, like let's say, I want to have 2 CPU but 60 gigabyte of memory, like memory optimized instance. Yeah, so Karpenter will request this instance for you. In general, Karpenter for you, it's like it's a middle layer which can help you to communicate with EC2 API, identify what the instance currently is available, because the biggest challenge for spot instances is sometimes spot instance is not available because, I don't know, Netflix released new show and request all of these instances inside in this availability zone, or some another customer.
Something like I want CPU optimized instance, but I cannot get it. I want general.
Yes, in general, you have to say in your deployment that's what exactly kind of instance you want to get. If you don't provide any information, Karpenter will request any resources for you, like general memory, which is available currently.
So that solution exclusively designed for AWS.
It's very good question because Karpenter, it's open source. So how you can find it, carpenter.sh. It's open source product, but as usual exists a but. It's created and currently supported by AWS, and it means like we have currently realization on the inside in EKS. But we are open for pull request. I mean, like as open source. If you're ready to say, hey, I want to create some implementation for GCP, go ahead. No, I mean, like you can do it. But currently, you're absolutely right, only for EKS. It's open source, free. Oh, I don't remember honestly. MIT potentially. I don't remember. Need to double check. I don't remember. But guys, I will be very honest with you. I would say currently documentation is not super ready to start your implementation for custom cloud providers. Currently, what I see, again, like as usual, previously someone asked what the drawbacks of API Gateway. Drawbacks of Karpenter, it's a product which is not like super young, but it's developing super fast. And like less than 1 year ago, we released on during the reInvent, and the current version 27.5. It means like people doing very quick new updates, new development, and so on. I would say that the current version of Karpenter, it's not super stable. I don't say it's not ready for production. It's ready for production. We already have a lot of customers who is using Karpenter, but be ready that you have to update your Karpenter pretty often. Like the same what's happened with Kubernetes, you have to update your Kubernetes cluster, because if you're not update Kubernetes cluster, you can lose support in general. So with Karpenter, like the same stuff.
Did you have a chance to run it? Did you have a chance to run it with Terraform?
Yeah, absolutely. We
take under consideration when running with Terraform.
Consideration? What do you mean consideration?
Anything that we like be careful with that, or like broken, or like.
What you should be careful that if you lost your controller, it means like you lost control all other nodes which created by this controller. So when you're working with Terraform, please make sure that you create new controller, and this controller will understand like I create a new version, but like I update it, not like super new version, so on. But in general, we supported installation through the Helm, Terraform. You can do it. I did it through the Helm installation. Yeah. So, but Terraform is also supported. Yeah. You're welcome.
Can you please give an example of the real application that use such amount of pods?
If you're working, for example, for enterprise like bank or I don't know some processing, sometimes exists a batch, not I don't know, three nodes something.
One pod for each data center.
Another example. I believe you know the company which is called Park Gaming. So they do some gaming and so on, and release some new, for example, new game. And during the release, you need more resources, which can be thousands of pods. So that's an example. But in real case, mostly the example when I show you like 3,000 pods, it's when you need to process a lot of data. When I say a lot of data, most probably it will be related to proceed with enterprise, bank processing, analytics, and so on. And for example, at the end of the month, you need to proceed, I don't know, millions of files. PDF, maybe something else, which contains some data, and you run distributed load, run this batch request, finished and deleted. But in general, it's like with these 3,000 pods, the main idea is to show how we efficiently request the right amount of resources, like 99%, and how fast we can delete through the Karpenter. Because if you work with ISG, you will see some not so fast, let's say. Who is speaking? I don't see. Ah, I see. Sorry. Sorry.
ETL pipeline, which process lots of data. It receives a job, it creates lots of pods, pods without a controller, which job just died. And Karpenter was the only thing that handled such loss perfectly. And I tried working with faster autoscaler, but it simply collapsed all nodes before the job was done. So these pods should never be touched because the memory state and Karpenter allows to configure itself to keep not like on.
So good example, just like ETL and production. So what I said, but as I said, it's super fast. Look at the release notes, subscribe to release notes, make sure that you know what's exactly happened. Another question from the same, yeah. So. If you have combined, I would say Karpenter not ready for you. I mean, like, it's not will be the best solution. If you not just like, if you have one load which should be spread between on-premise and use some cloud resources. In this case, Karpenter will not fit for you. If you have some spread, like application A inside in your on-premise, application B, it's part of the cloud, can be. But what's the most important, Karpenter will not work, I mean, like, classic autoscaler and Karpenter cannot work together because they will initiate this event. I mean, like when we have a pending pod, when I showed on the slide, when we have a pending pods for Karpenter and for classic autoscaler, it will be event that I need to request new resources. And if you install classic autoscaler and Karpenter at the same time, it will be a conflict. Who first will request? Potentially both will request resources and you will pay double time. Anyway. You're welcome. I think that's it. Thank you very much for so many questions. I have to select three, the best one. The first one definitely will go to you because spot instances is very interesting. The second one for you. Or you already got one?
I got one.
Okay, no, not for you. For good example of production ETL. Okay. And who else asked me question? Let's for the guy who asked the question regarding the production, not production, was the 3,000 pods. Thank you very much. Thank you very much.